we have an expression, an algebraic expression, and the directions say simplify the following expressions. And please notice we don't have any equations. We're not trying to solve for a or find the value of a. All we want to do is to take this expression and rewrite it in the simplest possible form. So let's think about what we have. We have 2a, and we are adding 5 more a. Now, I don't know what a is. I don't know the value of a. I don't know what it represents. Maybe it means apples. Or maybe it means artusios. It really doesn't matter. All I know is a has the same value as a. These mean the same thing. So if I have 2 a's and I add 5 more a's, how many a's total do I have? I've got 2 a's and I add in 5 more a's. So altogether, how many a's do I have? 1, 2, 3, 4, 5, 6, 7a. Hopefully you've noticed all we really needed to do was add the number in front of a. And that tells us how much a we have. Let's try another one. Number 2. We have negative 3d plus 4d. Again, what does d mean? I don't know. Maybe it means dollars. Suppose you owe $3. You are in debt. You find $4 on the ground. After you pay your bills, now how much money do you have? Well, you had negative 3. Think about being 3 steps to the left on the number line. You add 4, so you move 4 steps to the right. Negative 3 plus 4 gives you 1d, or we could just write d. So far, we've been working on combining or simplifying algebraic expressions where you have the same unknown in both pieces. Let's look at a third one. Look at example number 3. We have y plus 3x. Now, hopefully you're noticing there's a difference here. We've got y, and then we've got 3 x's. 1, 2, 3. How can I put those together when they're not the same thing? It's kind of like having apples and oranges. They're not the same. Which brings up the notion of like terms. We need to think about what it means for 2 things to be the same. And 2 things need to be true in order for terms to be like terms. First of all, they have to have the same variables. They have to have the same letter. A and A. X and X. Y and Y. The second thing that has to be true is they have to have the same exponents. The same exponents. For example, if I had 2 to the second power and 2 to the third power, those do not have the same value. They have the same base, but they don't have the same value. They are not the same. 2 squared is 4, and 2 to the third power is 8. They're not the same. So like terms have to have the same variable, and they have to have the same exponent. Let's just do a couple of examples. We're asking yes or no, are these like terms? First one, we have 5x and we have negative 18x. The question is, are these 2 terms like terms? Well, we ask, first of all, do they have the same letter? We have x, we have x. That's the same. Second thing we ask, do they have the same exponent? Well, it's understood that if there's no number written, this is really x to the first power. So yes, they have the same exponent. Yes, they are the same variable. So yes, these are like terms. Let's look at number 2. We have 1/2 m and we have 1/2 p. First question we ask, are these the same variable? Do we have the same letter? We have m and we have p. Of course, these are not the same. So no, these are not like terms. Third one, x to the 2nd power, x to the 4th power. Are they the same variable? Yes, they are. We have x, and we have x again. Second question, do they have the same exponent? X to the 2nd power, x to the 4th power. Different exponents, so no, not like terms. Again, 2 things need to be true if you want to say that you have like terms. Number 1, they have to have the same variable, the same letter. Number 2, they have to have the same exponent. So let's go back to number 3. Y plus 3x. Are these like terms? The answer, of course, is no. These are not like terms because we have 2 different variables. Because these are not like terms, I can't simplify this. I can't add apples and oranges. We have a 4th problem here at the bottom of the screen. Can we simplify this? We have 6p squared minus 6p. To simplify this, they have to be like terms. Well, first question, do we have the same variable? Yes, we do. We have p and we have p. Second question, do they have the same exponent? This is p to the 2nd power. There's nothing written here, so I assume this is a 1. Do they have the same exponent? No. That means these are not like terms. I can't combine them, so this is as simplified as it can be written. The last thing we want to look at is the distributive property. The distributive property is the first property we're going to be learning about in this course. We'll be learning in the next class about some other properties that we use in algebra. The distributive property is something that we use when we are multiplying something by an expression. Notice for number 1 we have 2 times the expression, the quantity x plus 3. We're multiplying. Now, let's think about what this means. This means I have 2 x plus 3s. Whatever x plus 3 is, I have 2 of them. So I have x plus 3, and then I have x plus 3. Let's think about this in terms of combining like terms. How many x's do I have? Well, I've got 1, 2 x's. And then I've got 3. 3 plus 3 is 6. So when you think about 2 times whatever x plus 3 is, you end up basically with 2x plus 6. Of course, I hope you notice, because you've seen this before, the distributive property basically means you're multiplying everything inside the parentheses by whatever's on the outside. I'm multiplying everything inside the parentheses by 2. So 2 times x is 2x. 2 times positive 3 is positive 6. Many of you will forget to multiply the 2 times the 3. Make sure everything inside those parentheses gets multiplied by whatever's on the outside. Think about if I were to distribute to you a worksheet or a test or a quiz, I would make sure every person in the class gets that piece of paper. That's exactly what the distributive property means. Look at number 2. This time, I am multiplying negative 3 times the quantity 4k minus 6. That means everything inside the parentheses is being multiplied by negative 3. Be very careful with your negative signs. Negative 3 times 4k is negative 12k. Secondly, negative 3 times negative 6. Negative times negative is a positive, so this is plus 18. Last one, number 3. I have negative 10 times negative 8x plus 9, and then I'm adding 8x to the end. So let's do the multiplication first. Negative 10 times negative 8x. Negative 10 times negative 8 is 80x. Negative 10 times 9 is negative 90. And then I still have this 8x that I'm adding to the end. Do you see any like terms that I'm allowed to combine? I hope you notice that we have 80x, and I have 8 more x that I'm adding. So how much total x do I have? Well, 80x plus 8x is 88x minus 90, and I'm done.